Sound, in reference to aeroplanes and their movement through the air, is nothing more than pressure disturbances in the air. It is like dropping a rock in the water and watching the waves flow out from the center. As an aeroplane flies through the air, every point on the airplane that causes a disturbance creates sound energy in the form of pressure waves. These pressure waves flow away from the airplane at the speed of sound, which at standard day temperature of 15 degrees Celsius is 340 meters per second. The speed of sound in air changes with temperature, increasing as temperature increases. In high-speed flight and/or high-altitude flight, the measurement of speed is expressed in terms of a Mach number, the ratio of the true airspeed of the aircraft to the speed of sound in the same atmospheric conditions. An aircraft traveling at the speed of sound is traveling at Mach 1.0. Aircraft speed regimes are defined approximately as follows: subsonic, Mach numbers below 0.75; transonic, Mach numbers from 0.75 to 1.20; supersonic, Mach numbers from 1.20 to 5.0; hypersonic, Mach numbers above 5.0. When an aeroplane is flying at subsonic speed, all of the air flowing around the aeroplane is at a velocity of less than the speed of sound, known as Mach 1. Keep in mind that the air accelerates when it flows over certain parts of the airplane, like the top of the wing. So an aeroplane flying at 223 meters per second could have air over the top of the wing reach a speed of 268 meters per second. How fast an airplane can fly and still be considered in subsonic flight varies with the design of the wing, but as a Mach number, it will typically be just over Mach 0.8. When an airplane is flying at transonic speed, part of the airplane is experiencing subsonic airflow and part is experiencing supersonic airflow. Over the top of the wing, the velocity of the air will reach Mach 1 and a shock wave will form. The shock wave forms 90 degrees to the airflow, approximately halfway between the leading and trailing edge of the wing. It is known as a normal shock wave. Stability problems can be encountered during transonic flight because the shock wave can cause the airflow to separate from the wing. The shock wave also causes the center of lift to shift aft, causing the nose to pitch down. When an aeroplane is flying at supersonic speed, the entire aeroplane is experiencing supersonic airflow. At this speed, the shock wave which formed on top of the wing during transonic flight has moved all the way aft and has attached itself to the wing trailing edge. Supersonic speed is from Mach 1.2 to 5. If an airplane flies faster than Mach 5, it is said to be in hypersonic flight.